Hi guys, welcome to today's video on our graph series. I am Chinyel, a software engineer at Microsoft Dublin, Ireland. Today we'll be solving a very popular question titled Number of Island. This question is Leetcode number 200 and it is very popular because it is frequently asked in Google interviews. So I would begin by reading the question, pointing out exactly what the question requires from us. Then I will explain my proposed solution using a pseudocode so you can implement it using any language of your choice and get the same result. I will also implement the solution in JavaScript and explain the time and space complexity of the solution. All right, let's get started. The question says, given an M by N 2D binary grid, which represents a map of ones, land, and zeros, water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. For example 1, we can say that the output is 1, which means that the number of island is 1. And from the input, you can see that this is the given island. They are all ones and they are all connected vertically or horizontally. In the second example, the output is 3, which means that the number of island is 3. And from the given grid, you can see this is the first island. They are all ones and they are all connected either vertically or horizontally. The next island is just this single node because it is 1 and is surrounded by water. The last island is this one. To solve this problem, I will use a nested loop to traverse the grid, looking for new islands. I will know I just encountered an island immediately I come across a node that is a land and has not been visited before. Once I encounter a new island, I will increase the number of islands count and use a recursive function to mark all the nodes that are part of this new island as visited to avoid counting it as part of another island. Let me give you a visual example of what I mean. I have copied out the examples into this Word file to enable me give you a visual explanation. So we are going to be using the green color to show the nested loop traversal, and we are going to use the red color to show the recursive call traversal. Our recursive call basically helps us to mark all the nodes that are part of a given island as visited. And we achieve this by, first of all, changing the value of that node to 0. That is our own way of marking it as visited. And then calling this recursive function on all the adjacent nodes of this node. Also, our recursive function is going to have some conditions to return when we visit a node that is out of range, or when we visit a node that is water, or a node that we have visited before. That is basically a node with a value of 0. So the nested loop starts with the first node. The first node, because it's 1, it is a new island, and because we have not visited it before, we increase our island count to 1, and then we call the recursive function on it. Calling the recursive function on it changes its value to 0, and then calls this recursive function on all the 4 adjacent nodes of this node. Calling it on the first one returns because it's out of range. Calling it on the second one returns because it's out of range. Calling it on the third one changes its value to 0 and also calls the recursive function on all the adjacent nodes of this particular node, which is this node, this node, this node, and this node. Starting with the first one, this one returns because the value of this one is now 0. This one returns because this is out of range, and then it goes to the third one. In the third one, it changes the value to 0 and then calls this recursive function on all its adjacent nodes, which is this guy, this one, and this one. Starting with the first one, it calls it on this guy, but this guy value has changed to 0, so it returns. Calls it on this guy is out of range, it returns. Calls it on this guy is 0, it returns. And then it calls it on the last node of this guy. Calling the recursive function on this guy changes the value of this to 0, and then calls the recursive function on all the 4 adjacent nodes of this node. Starting with the first one, calling the recursive function on this node changes this guy to 0, and then calls the recursive function on all its adjacent nodes. Starting with the first one, calls it on this guy. The recursive call on this guy changes this value to 0 and calls the recursive function on all the adjacent nodes of this node. Calling it on the first one returns because it's out of range. Calling it on the second one returns because this is now 0. Calling it on this third one returns because this is now 0. And then calling it on the fourth one. Calling it on this one changes this value to 0, and then it calls it on all the adjacent nodes of this particular node. Starting with the first one, this one is out of range, it returns. On this one, this is already 0, it returns. On this one, this is 0, it returns. And then on this one, the recursive function call on this one changes this value to 0, and then calls the same function on all the adjacent nodes of this node. Starting with the first one returns because it's out of range. The second one returns because it is 0. Calling it on the third one changes the value to 0, and then calls the same recursive function on all the adjacent nodes of this node. Starting with the first one, this guy returns because this value has been changed to 0. On the second one, this also returns because the value is 0. On the third one, this returns because this is 0. On the fourth one, this returns because it's 0. And at this point, the recursive call on this guy completes, and then we return back to this guy. On this node, we started the recursive call with this first node, the second node, and then the third node. We never completed for the node. So at this point, we call the recursive function on this node, and this is 0, so it returns. And at this point, the function call on this guy returns, and it comes back to this guy. The recursive call function on this guy also completes since this was the last adjacent node of that node, and the function call on this one has already completed, which completes the function call on this guy, and then it returns back to this guy. Then again, the function call on this guy also completes since this guy is the last adjacent node of this guy. And therefore, since the function call on this guy returns, the call returns back to this guy. And at this point, this is just the first adjacent node of this guy. So as a result, we go to the second adjacent node. Calling the recursive function on this node returns since this value is now 0. We call it on the third one, it returns since this value is now 0. We call it on the fourth one, it returns because this value is 0, and the recursive function call on this guy completes, and we return to this node. This is also the first adjacent node which just completed, so we move to the second node. Calling the recursive function on this node returns because the value of this guy is now 0. Calling the recursive function on the third adjacent node returns since this value is 0. Calling the recursive function on the last adjacent node of this node also returns since it's 0, and the recursive function call on this guy completes. It returns back to this node. And at this node, since this is the last adjacent node of the node, it returns back to this guy. And on this guy, we just completed the recursive call on the third adjacent node. So we call the recursive function on the fourth adjacent node of this node. And it returns because the value is now 0. And this completes the recursive call on this node. Now we are back to the first node. And we just finished with the third adjacent node of this particular node. So we call the recursive function on the fourth adjacent node, which is this guy. But this guy also returns since the value here is now 0. And This means that we have successfully finished the recursive call on this guy. And just as we expected, you can see that the recursive call helped us to visit all the nodes that are part of this island. So the nested for loop moves to the second node. And on the second node, this node is now 0, so it moves to the next node. This node is now 0, it moves to the next node. This is 0, it moves to the next one. This is 0, it moves to the next one. This is now 0, this is 0, this is now 0, this is 0, this is now 0, this is now 0, this is 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 0, and this is 0. And this completes the nested for loop. So we return the number of our island, which is 1. Let's do the same thing for example 2. So for example 2, we start with the first node. This is a new island because this node is 1 and it has not been visited before. So the number of our island, we increase it to 1. And then we call our recursive function on this node. So the recursive call on this node will change this value to 0. And we'll call the same function on all the adjacent nodes of this node. Starting with the first one, it will return because this is out of range. The second one will return because it's out of range. And on the third one, the recursive call on this node will change this value to 0 and call the same recursive function on all its adjacent nodes. Starting with the first one, this will return because this is 0. The second one is out of range, it will return. The third one is 0, it will return. And then the fourth one is another land. So the recursive call on this land would change this value to 0 and call the same recursive function on all its adjacent nodes. Calling the adjacent node on the first one, this is a land. So the recursive call on this node changes the value to 0 and calls the same recursive function on all its adjacent nodes. Starting with the first one, this is out of range, it will return. On the second one, this is already 0, it will return. On the third one, this is 0, it will return. On the fourth one, this is 0, it will return. So the recursive call on this guy just completes and it returns to this guy. And then on this guy, we just completed with the first adjacent node. So we'll move to the second adjacent node. Calling the recursive function on the second adjacent node returns because the value is now 0. On the third node returns because it's 0. On the fourth node returns because it's 0. And the recursive call on this node completes and then it goes back to this guy. Because this is the last adjacent node of this guy, this also completes and returns back to this guy. And then to complete the recursive call on this guy, we need to call it on its last adjacent node, which is this guy, but it returns since this value is 0. And at this point, we just completed the recursive call on this guy. So at this point, the nested loop goes to the second node. And in this node is 0, it goes to the next node, this node is 0, it goes to the next node, this node is 0, it goes to the next node, this node is 0, then again this is 0, 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 and then it meets a new land. We just found a new island, therefore we increase the number of island count to 2. And then we call the recursive function on this node. Calling the recursive function on this node changes this node to 0 and calls the same recursive function on all the adjacent nodes of this node. Starting with the first one, the recursive call on this guy returns since this value is 0. The recursive call on this one returns since it's 0. The recursive call on this one returns since it's 0. The recursive call on this one returns since it's 0. And the recursive call on this node completes. So the nested loop goes to the next node. This is 0, it moves to the next node, this is 0, it moves to the next node, this is 0, it moves to the next node, this is 0, it moves to the next node, this is 0, and it moves to the next node. We just encountered a new island. So we increase the number of islands to 3 and call the recursive function on this node. Calling the recursive function on this node changes the value to 0 and calls the same recursive function on all its adjacent nodes. So starting with the first adjacent node, the recursive call on this node returns because this node is 0. The recursive call on the second adjacent node returns since this value is 0. The recursive call on the third adjacent node returns since this is out of range. And then we call the recursive call on the fourth adjacent node. This recursive call on this adjacent node changes its value to 0 and calls the same recursive function on all its adjacent nodes. Starting with the first one, The first one returns since it's 0. The second one returns since it's already 0. The third one returns since it's out of range. The fourth one returns since it's out of range. And finally, the recursive call on this guy completes and it returns to this guy. And this also completes. So the nested loop goes to the next node, which is the last node, and therefore it completes. So at the end of the day, we return 3, which is the number of island. Let's represent this in a pseudocode. The first thing is to assign the number of islands to a variable count, which is 0 at this point. Check if the grid is null. If it is null, just return 0. Create a nested loop to traverse the grid. If a node value is 1, we just found a new island because the node is a land and has not been visited before. Since we will be changing the value of any land we visit to 0. This is our own way of marking the node as visited. That is by changing the value of the node to 0. And since we just found a new island, we increase the island count by 1 and then call a recursive function on the node. But one thing is remaining. Let's implement this recursive function. This recursive function is simply used to visit all the nodes that are part of an island. So we are going to first check if the node is 0. If it is 0, simply return because it means that the node is either 0 or has been visited before. The next thing is to check if the node is out of range. If it is out of range, we simply return. Next, we mark the node as visited by changing its value to 0 and call this recursive function on all its adjacent nodes. And finally, we return the count, which is the number of islands. Simple. Let's delete the pseudocode and implement the solution in JavaScript. Let's set count to 0. If grid is null, return 0, that is count. Define the length of row and the length of column. The length of row is equal to the length of the grid, and the length of the column is the length of the first grid array element. Let's create the nested loop. For let row equal to 0, row less than row length, row plus plus. For let column equal to 0, column less than column length, column plus plus. If the node value is 1, we just found an island. So we increase the number of island counts and call the recursive function on the node. Now, let's implement the recursive function. If the node is out of range, return. If the node value is 0, return. Now, mark the node as visited by changing the value to 0. Call this recursive function on all the 4 adjacent nodes of this node. Return count. Run and submit code. Great job! The time complexity of this solution is O of n times m, where n is the number of rows and m is the number of columns. This is because we iterate through each cell in the grid once using the nested loops. The space complexity of the solution is equally O of n times m, where n is the number of rows and m is the number of columns. This is because the recursive function uses a call stack, which in the worst case scenario, where the entire grid is part of a single island, the depth of the call stack will be O of n times m. Thanks for watching till the end. If this video was helpful, please give it a thumbs up and hit the subscribe button to see more videos like this in the future. If you want me to solve any specific graph problem, leave a comment and I will add it to the list of my videos to create. Thanks again for sticking to the end. See you in my next video. Bye!